Hey everyone, welcome back to another installment in our Intro to Python series. In this video, we will be exploring error handling in Python using try and except blocks. This is especially useful for when you might want to run code and are unsure if any errors might pop up. The idea is to catch these errors or catch these exceptions and handle them in a particular way. So on your screen now, you will see the skeleton code outlining the syntax and structure of a try and except block, and we'll quickly go over what each of these keywords mean. So the try block lets you test a block of code. This is where you'll put the code that might raise an exception. The except block lets you handle the exception, and you can choose to handle it however you'd like. The else block will execute if there's no error. So suppose we work through all the code in the try block and nothing raises an exception, then the else block will be executed. And last, the finally block lets you execute code regardless of the result of the try or except or else block. So it's basically code that will always be executed. Before we start working with our try and except blocks to handle errors, let's quickly look at what an unhandled error might look like. So in order to induce an unhandled error, I'm going to write a quick function called divide, and I'll say def divide, and it takes in two parameters, a and b. And all we're going to do is return a divided by b. And in order to test this, let's just say print divide, and then we'll just divide 1 by 1. So this should output a float value of 1, which it does here. And next, let's induce an error. So let's say what happens if we divide by 0. We know that this is impossible, so Python should complain. So we run it, and we get a traceback error. So if you've never looked at a traceback before, it displays really useful information. It'll tell us where the error is and what exception is being raised. So let's just walk through this. First, it tells us what file we're working in, and then it'll tell us the line. So it's saying that line 5 is giving us a problem, and it's when we have this print statement which calls our divide method that we wrote, and it's with the parameters 1 and 0. This later gets traced back to line 3, and it says in divide, so it's in our divide function here, and the error is when we return a divided by b, and in this case a 0 division error is thrown. This is what's being thrown. So this is what it might look like if your program crashes and has an unhandled exception. Now that we've seen this, let's work with our try and except block and handle this kind of exception. So let's now work with the try and except block. So what I'm going to do is just copy this line, or cut it now, and put it in our try block. And now we're just going to say except exception. And we're just going to want to print something went wrong. You don't want to leave a vague exception like this, but just for this example, we will. So now in our else, this will get executed if nothing goes wrong. So we'll just say print nothing went wrong. And in our finally, this will be printed no matter what. So we'll say end of try except block. So if we save and run, we see that we do not crash the script. The script does not crash. We don't have a traceback error because we are handling this exception. So we're saying it's the same call to divide with the parameters 1 and 0, and we do have an error here. We have the same 0 division error, which is being handled by our except block where we say except exception. And when we do have an exception, we're saying we just want to print something went wrong, and then our finally block is being executed because this will be executed no matter what, and we're saying end of try except block. So as I said before, having a vague exception like this is considered bad practice. You want to have the most specific exception as you can. So in our case, it'll be 0 division error. And if we save and run, we'll notice that it has the exact same output as before. Just in this time, we are trying to catch the most specific error. So what's nice about this try and except block is that we can catch multiple errors. So I'm going to induce first an error that isn't caught. So first we want to just get rid of the error that this divide method raises. So now we're just going to make sure it can do the division. So we're just dividing 1 by 1. And next I'm going to just create an empty list called L, and I want to just print the item at the 0th index of our list. And this should give us a traceback error because our list is empty, and so it doesn't know what it means to get the first item. So if we run, right, we get our traceback. So what you'll notice here is our divide is still printed, and our finally is still printed. Even though we had a traceback error, right, our finally was printed no matter what. Whatever was in our finally block was ran. And next we have our traceback error, and we get where the error is, so it's line 8, and the type of exception that it's raising is an index error. So what we can do here now is try and catch this. So we can say except index error, and we'll do the same thing. We'll just say print something went wrong, just for this example. And if we save and run, we will see that our division goes and works completely fine, right? We're just dividing 1 by 1. And then when we try and access the 0th index of our list here that's empty, we'll get an error and handle it, and then we'll exit the try and except block. So one thing that's really useful is sometimes printing the error message associated with the exception that was raised. Right now we're just printing something went wrong, but this doesn't really tell us what the error is. So what we can do here is using the as keyword, we can say accept division error or 0 division error as E, and now we just print out E. And we'll do the same thing with this index error. So we'll say accept index error as E and print out E. So now we'll save and run. And so it says, we do our division perfectly fine. And now the error that we're printing out here is list index out of range. So this is the error that we are getting. And then we exit our try and except block. This time, let's induce the error in our division. So this will get handled first. Notice that we would have two errors, right? These are both invalid things. To divide by 0 and then access an empty list from the 0th index. However, the index exception or the index error will not get printed out because we have this error first. Our divide error will happen first. So we'll print and or save and run. And as you see, we get our division by 0 printed out, and then we have our end of try and except block printed out. So one thing that I actually forgot to show that I'm remembering now is looking at what happens when the else block would be executed. So right now, every single time that we run our code using the try and except block, we've induced some kind of exception to be raised. So in this time, I'm going to not induce any exceptions. So this time, I'm just going to have our divide function work. So we'll say divide 1 by 1. And our print, we're just going to print out the list, our empty list here. So this should not raise any exceptions, and our else block should be executed. So let's save and run. And yep, as we see, we get our statement of nothing went wrong printed out, and this is because the try block didn't raise any exceptions, so the else block is executed, and then of course we have our finally block being executed as always. So I think that's going to wrap things up for this video. I know that this video is on the shorter side, but that doesn't mean that it was any less challenging than other videos, so feel free to leave questions or concerns down in the comment section down below. All the code in this video will be available on our GitHub repository, so feel free to check that out if you want to run any of the code on your local machine and just play around with it. Other than that, I hope everyone is doing well and staying safe during this hectic time, and thanks for watching.